What's up everyone, this is Ryan here, and you are watching episode 49 of my live stream Q&A. So, yeah. So a couple things about today. You'll notice that I'll be speaking a little bit quieter than normal, possibly. And that's because there's still tradespeople outside my deck currently painting. And also if you hear construction noises, that's sort of from the same issue. For those of you who have no idea what I'm talking about, starting about a month ago, they began renovating the decks on my new apartment. New as in I moved here recently, but the apartment itself is quite old. I think it's from the 60s or something. So I've been replacing the decks, and I've missed a couple of live streams as a result because they generally get started right at 9 o'clock. So anyways, today we'll just bear with it and barrel through. So for today, I plan to do Q&A, of course, but I also wanted to take everyone through something I learned recently with the Kotlin programming language. And I think this is something you could still figure out a way to get it to work with Java, but it's definitely going to be made a little bit easier with Kotlin, which is basically all I've been thinking about lately. Before I get to that little mini lesson, just some announcements. So I'm finally sort of at the tail end of several projects that I've been working on at the same time. So I am still exhausted today, as you can see, but luckily pretty much starting next week I'll have a little bit more spare time, and I'm going to start once again looking at releasing some more videos. I will definitely have a lot more spare time in September, as I'm planning to quit my day job in short order, which I'm quite excited about. So yeah, and at that point I will reestablish a actual regular consistent streaming schedule and a more regular upload schedule for my videos. But this summer has basically just been dedicated to me working on several projects and also just really trying to increase my Kotlin knowledge drastically. So as a result, it is a little disappointing, but I haven't had time to make a lot of videos lately. So anyways, that's fine. What's up, everybody? We got Linksy, Ubaraj, and Jesu, I'm going to assume. I almost pronounced your name in a Mexican way, Jesu, but I believe that's an Indian name. So welcome, everyone. Thank you for joining me. Oh, wow, we have 11 people right off the bat. That's bizarre. It's going to be a good day. So anyways, yeah, that's it for announcements. My schedule is finally opening up, and lots of great things are happening. I can't talk about any of them still yet, but very soon I'm hopeful to be able to talk about the commercial app project that I've been working on with my friends Darrell Bitsi and Davor Maric. And those are my programmers, and we've been working on a project together. And we're hopefully pretty close. We're going to try and push for a beta release by the end of this month, but we'll see how that goes. We're all super busy, so it is what it is, but that's totally fine. Anyways, I think I'll shut up about that stuff, and let's get into something educational. So, yeah. So what I wanted to talk about today, let me back up a little bit. So I wanted to discuss something which is probably going to be one of the more generally relevant patterns, for lack of a better word, or constructs that you're going to want to know as a developer. And I think as I explain what this pattern is, you'll start to understand why it's so generally applicable to all kinds of things. So first and foremost, I'm just going to pull out the old whiteboard and draw a little diagram. been a while since I pulled out the whiteboard. Okay. Okay, so no, this is not supposed to be phallic or anything like that. What does this represent, just really simply? So what I'm showing you here is basically what I would describe as an event stream. So when we're talking about RxJava and reactive programming, this is basically what we're talking about. And so the eyeball basically means user interface, or what the user will see, or you can think of this as the front end. Then you can think of this as this half over here as the back end. Now, the pattern I'm going to be showing you is going to be called the either monad, and I'll write this stuff out in the notepad, so don't worry about it. And why it's so generally applicable is because this little model here can basically model almost any operation which sort of a separated application could represent. So for example, let's say the user hits a login button and then a message gets sent to your Facebook service, for example, or your retrofit service or something like that. And we can kind of represent that here. I'm going to write with my, I'm actually left-handed, so this will be a very ugly R. That's actually not too bad. So that can represent like retrofit. And what these two circles represent is either going to be an E or an S. E stands for error, S stands for success. So super complicated, isn't it? So really what I'm showing you here is just imagine an event stream where we're sending a message. So if some event happens, the user hits the login button, a message gets sent to the retrofit service, and the Facebook, on Facebook's end, they can either return us with a success value or successful result, or they can return us with an error, let's say if the login credentials are wrong. So I kind of want everyone to just keep this in mind, because this is all that we're going to talk about. We're going to talk about basically what gets sent through this pipeline and how to do this kind of operation better. And it doesn't have to be retrofit, it could be a database, it could be really any kind of low-level service, or you know, it's sort of something generally applicable to communicating across different components of your application. So everyone keep that in mind. So what we'll switch to Notepad here. So today's mini lesson is going to be about the either monad. Now right off, oops, not monad, monad. Now a couple things about this. This comes from functional programming. What does monad mean? So here's the thing about this. I could explain to you what a monad is, but it's not actually going to help immediately. So if you're wondering what is this thing here, the either monad, to be perfectly honest, these names don't particularly help with the understanding of what this thing does really, unless you're a mathematician, which I wouldn't say I'm bad at math, but I wouldn't say that I'm a mathematician either. So either, amusingly enough. So it's a concept from functional programming. And what does monad mean? Like I say, maybe I'll try and talk about that later, but just don't really worry about what this thing is called, and let's just look at what it does, because that's really the most important thing. So what we're really talking about here, where is my notes? There we go. So, and am I in the right mode. There we go. So we're talking about a way to handle callbacks slash event results. I'm just going to try and do this stuff off the top of my head here. So we want to be handling callbacks of some kind. So as I said before, oh, that's totally the wrong, sorry, I switched to the wrong scene there. So we're handling some situation where our application sends a message to some service and is expecting some kind of result. Now the big issue with that type of operation, of course, is that the result isn't always going to be the same. In fact, it could be an error, it could be a success state, it could be a loading state, it could be kind of several different things. So what we can do in order to sort of capture all of that in one object is using this thing called an either monad, or as I will call it, I'll actually refer to this as a result wrapper. So when you're looking this up in other places, you're going to want to use this term, either monad. Today I'm going to be calling this a result wrapper because that is what it is to me. I'm not just deliberately trying to add new names here. I just feel like this is a better way of describing what this thing is. Let me just double check the chat to make sure people can hear me. Perfect. Okay. So let's get into some code examples. So a couple of people might be wondering why I haven't added any new episodes to my Let's Build a Kotlin calculator application tutorial. And the reason why I haven't been adding anything to that is because I've been intensively studying Kotlin lately, and I figured I would wait on it until I've done more extensive study, and then that way the tutorial itself will be that much better. And one of the things I've already decided to change is my result, expression result class. So we'll just do a little bit of live coding here, and we'll see how it goes. So this is my Kotlin MVP tutorial repository. You can find it in the description box below. And so one of the things I did before is if I open up the project and I navigate to the domain package and domain model, in that package you'll see an object called expression result, or it might actually just be called expression in the code that you'll be seeing in the repository because I haven't updated it yet. But this expression result object basically looks like this. Again, it'll probably be called just expression. So it's just a class which has a private constructor, which means I can't directly invoke the constructor. That's all that means. And we have a variable result and a variable successful, or I probably should, that's a decent name. I might call that is successful or something a little better. So essentially what I was trying to do with this object here was capture something pretty similar to my diagram. We've got the Boolean kind of represents whether it's successful or not. And then the result can either be the result of the calculation, or it can be like an error message. Now the problem with doing things this way in particular is that the logic of determining whether this thing is successful or not, and determining its parameter, whether it's an exception message or the actual result of a mathematical expression, which is what this app is designed to calculate, it's kind of dictated almost externally in places that I'd rather not have it dictated. So what we're going to do is we're going to solve sort of several problems at once by rewriting this object as a what I will call a result wrapper. So what we'll do is just pull up my sample code here. And I won't spend a huge amount of time on this just because it can be a little bit laborsome to explain, but let's just get started right away with a little bit of Kotlin. So first off, I'm going to just delete that. We'll zoom in a little. And so just for everyone not familiar with this project, it's just a calculator. It's just a really, really, really well-built calculator. And the reason why I built it is this was the first Kotlin application I ever made. And my suggestion to people learning any new topic or programming language is if you want to learn it sort of faster, then build a simple application really well. And the reason why I think that's a good idea is because when you build a simpler application, then you're not spending a huge amount of time solving problems specific to the problem domain, and you can kind of just focus in on learning the sort of topics you're interested in and focusing on the language constructs as opposed to solving problems in the problem domain. That's a redundancy, department of redundancy there. Anyways, just let me catch my breath for a sec. Okay. Sorry, one sec here. So we're going to rename this class first. Actually, no, I'm going to keep it just named expression result. And we're going to change a few things. So I'll get rid of this private constructor crap here. In fact, we are going to entirely just get rid of our constructor. And we're instead going to make this into a sealed class. So just really quickly. So Kotlin tip. What is a sealed class? A sealed class allows you to create a restricted class hierarchy. So what does that mean in English? Oh, where is it? Basically, what it's going to allow us to do is when we would want to use a sealed class is when we want a very, very sort of specified and finite construct which is capable of representing, say, one superclass with different subclasses. So let me just keep going through the example and hopefully it'll be a little easier to understand. But we basically want the ultimate goal of this pattern is we want one class or one type which is capable of representing different states. So error state and success state. Yeah, I'll carry on from there. As I'm talking, I'm trying to think of a bit how to sort of arrange this lesson. This is totally off the top of my head, so you'll just have to bear with me. So we've first made it a sealed class, so that's the first thing we'll do. And then we're also going to create some type parameters here for this application. And we're going to use the out keyword from Kotlin. So what does out mean, just really briefly? It kind of just means that at a certain point we are going to want to see this variable come out of this class. We can also use the in keyword for sort of more parameterized types. All right. So what we have here, so we're going to specify two different types. So let's go back to the functional programming monad stuff. So really quickly, either monad. So the either monad can essentially be summarized like this. EV, so E stands for error, and V stands for value. I totally screwed that up. Here we go. And so, and the important thing with either is that by convention, E is always on the left, V is on the right. So we could even rewrite this again as left, right. So basically what this is saying is that we have one object with two types. We can call them left and right. We can call them just arbitrary types. I'm just trying to think. I don't think they're called wildcards specifically in Kotlin, but in Java we would call this like a wildcard. But this basically means that we will specify the type later in the class which implements the expression result. So let's carry on here and just write out a couple of different things. So when you're making a sealed class, you'll generally want to create subclasses within which represent the class hierarchy which you would like to build. And so what that's going to look like is first one will be data class value out v. I'll write it out and then explain it. That's a little bit easier. And we'll say, oops, extends result v. Okay. And that's actually going to be expression result. There we go. And then we'll make another one, and this one's going to be called, of course, error. And that's going to be out e. Error e. E. Nothing. All right, so already you can probably start to see here. So what are we saying? We're saying we have two specified subtypes which extend our supertype expression result. So already you can see we're starting to build some kind of structure which will be under one single superclass, but it's capable of representing two subclasses which have sort of a more detailed function. So value and error. Just really quickly, again, since we specified these parameters up here as out, then what we can do is we can get them out of this function down here. So that's why we said out. And so when it's an error case, we actually don't want to even look at the value because the value will be null or non-existent or nothing. So that's another sort of type in Kotlin, the nothing type. And this basically just means null, essentially, a similar idea there. And of course, when there's an error, we want to create our error object down here. So we will still need this companion object. And this thing I'm just going to copy and paste in here because we don't really have time. So what I did before is a similar idea. We had create success model and create failure model. What we're going to do now is we're just going to have one single function here, which includes exception. And that's again going to be expression result. And what does this function do? So we've got a lot of jazz going on here. We've got this inline keyword. Really quickly, let's see. What is an inline function? Basically, it specifies to the Kotlin compiler that we would like this function to be embedded in the source of the generated class instead of creating an object out of the function. So again, this is a more advanced topic, but just simply put, you'll want to use an inline function in certain cases where you'll run into a situation where using lambda expressions create extra objects which the garbage compiler has to deal with. So yeah, just a very small point there. And so again, we're specifying the type here. And then we have exception and v. So here I'm actually kind of stating specifically that I always want this side of the either monad or our result wrapper to be of the type exception. And you might be wondering, what the heck is this if you're a Java developer? this is really just saying that we're going to be passing in a function here, and it's going to be called function. We don't know what function it is, since it's just an abstract of a function. And the way that we actually call the function that we pass in is we call function.invoke. So this is some crazy Kotlin stuff, which is probably going to be bending your mind, but this is some of the stuff I've been learning about Kotlin, which is absolutely amazing. So we're not quite done yet. We've got this build function. And then what we'll do is we'll add one more inline function. Let's just clean this up a little bit. So we'll get to Q&A soon. I realize I've been talking for nearly a half hour, so don't worry about it. Okay, and so this is going to be the function that we actually call to build our result model. And of course, we're going to need to specify our types. And this V here represents a nullable type in Kotlin. So basically what's going to happen here, just give me one moment. Sorry, I'm just going to pause for one quick second and run a quick commercial break, and we will be right back. If you've liked the show so far, please hit the like button down below. Okay, and we are back. Sorry, I've just got like 50 windows open. I'm trying to select the correct ones here. Okay, here we go. So anyways, what's going to happen, so when we want to actually build this thing, we will be calling the build function. And global address result build. And sorry, I'm just trying to read my own code here. All right, well, this is what happens when you're tired and you're trying to do a lesson off the top of your head. Result.build document, so we specify the type. Okay, anyways, moving on. So when we want to actually build this object, what we'll do is we will pass in a function. And where is... Sorry. Sorry, I've just like utterly derailed myself here because I'm trying to understand exactly how this thing works in order to explain it. So we say result.build, and we pass it in a value. And where do I specify the error is the thing that's confusing the hell out of me. Okay, well, you know what? We're basically just going to have to move on here. I thought I was going to be able to explain this relatively easily, but I'm just looking at my code on the other side here. And yeah, flowable just.result build. And we give it the document. So we specify the type. And then we say result.build. Value. Huh. Yeah, I'm going to have to look at this one again later. And we'll just move into Q&A. So the thing that's going on right now is I'm trying to find the place where we invoke the either monad, and yeah, okay. Let's just move into Q&A for now. What a fail. Okay, anyways, moving on. So what questions have we got here? So hopefully everyone was able to pick up a little bit of information from that. That was basically the worst demo I've ever done in my life here. To specified subtypes. Sure, so I've got a question from Taha Malas, and we'll move right into that. So where can I find some advanced resources on learning Kotlin? And thank you for stopping by, Taha. So Taha asks, where can I find some advanced resources on learning Kotlin? So there's a couple different resources I've been looking at lately. So first, I highly recommend How to Kotlin from, I believe, Kotlin Con 2018. Let me just double check on that. Oh no, it's from Google I/O. Sorry, my mistake there. So Google I/O 2018, How to Kotlin, and it's by Andrei Breslav, was it? Yep. And this is by Andrei Breslav, who is the lead Kotlin language designer. So this is the first thing I would strongly suggest people look into is this video. It took me a little while to get through it because it'll really, if you're used to coding Java constantly and you're like a Java developer, then what'll kind of happen is you'll have to rethink how you're approaching writing Kotlin. Instead of just like rewriting Java in Kotlin, you'll want to start learning how to take advantage of the features of Kotlin. So this was a really instrumental video in kind of helping me do things like, instead of creating, for example, enhanced for loops in Java, so that would be something like for I'll see if I can remember how to do this off the top of my head. I'm not sure if I can. Type t collection, and then you would say t dot sum method, or t dot do something. I'm probably screwing this up because I haven't written Java code in quite a while. So it's something as simple as, instead of just using, for example, like for loops, if you have to iterate over a collection, you could just say collection dot for each, and then you're given a code block to operate in, and then you have this thing called it, which stands for, it would be equivalent to like t, or you don't even actually have to include it. You can just have it implied in the code block itself. And then you could just say it.do something. So right off the bat, one of the cool things about Kotlin is the syntax itself is just a lot more idiomatic and easier to use. And once you start to understand the little things behind it, like for example, that there's this magical parameter that is just given to us up here, or we could specify t, and then we could write that as t.do something. So even something as simple as just using for loops intelligently will help you a huge amount. Another thing that I was learning from that particular video is how to use extension functions, for example. Extension functions are incredible because you can extend the functionality of a class or property or function without modifying the existing source code of said object, for lack of a better word. That's a really incredible feature. There's just a lot of things involved in Kotlin, which I'm super excited about. So the question was, what are some advanced resources? This was a very great resource. Just trying to think where else. Number 2, check out Medium articles on Kotlin. I'm trying to think, do I have any specifically which would be useful? I can't think of any. I've looked at a bunch so far. I can't think any that stand out super powerfully. The main thing about it is the documentation can leave you with many questions about how to apply the different features. So I would say refer to it sparingly. The documentation will help you find like a series of topics, but you're really going to have to search for yourself where to apply them in code, is generally what I'm finding as I'm learning Kotlin. So yeah, that's basically the gist there. Let's see if we got any other questions here. Okay. So we got that. I wish I had code to demonstrate this. So, so the question is, where? Let me write your name first. That would be helpful. So Yubaraj asks, where would we place this result, or I'll just use a generic term, result wrapper class in code. So I can't answer that. So basically, let's hop back into the code here. So you're going to be using this thing pretty much at the end point. You're going to be creating the result monad at sort of the end point of the back end and then sending it back to the front end. So what that would look like in code is, for example, I was hoping to convert this over live, but in this particular application, we'll open up the back end, and let's see here. Repository, so that'll be data, validator info. So return true. So what you would basically want to do is you'd want to open up, so whatever is your backend service, or I guess that would be the middle flowable of type T. So what you'd want to do is, assuming you have like an interface between your backend and your front end, which you should be doing, you would take that interface and you would have its the particular methods in it. You would make the result wrapper as its type, so expression result. Expression result, and then you would specify in here the types that you want, so that would be exception, and then I think we could probably use expression data model here. We can actually just use a string, because that's all I really care about. So we're going to specify the type there. Flowable, expression result, exception. String. Okay. And why are you still giving me an error? Expression is never used. That's fine. Expecting a top-level declaration. Wow! I'm doing so well today. Just one moment. Sorry folks, this is what happens when you're brutally underslept. So I wouldn't actually need to specify that up there. So we just say base use case. So again, this might confuse people. What is a use case? Just think of this as like a layer between my back end and my front end. It's like a middle domain layer, if it's confusing at all to people. And it only has one method. It just executes. And the return type is our result wrapper. So that's basically where we'd want to see it in the interface. And then if I were to hop into the use case itself, which is, where is it? Domain. There we are. So evaluate expression is our use case. So then I'd want to change this over to say, let's see here, no arguments expected. So this is going to be exception and string. Extends base use case. So I wouldn't specify that, I don't think, because that doesn't have a type anymore. Okay. And then I would, we'll fix this in here. So just give me a moment to clean the code up and then I'll go over it. So exception, string. Okay, so then we're specifying the return type in the class which implements from our interface. And so what we do is we would perform our calculations and then towards the end we would say, now I might not actually want to use flowable.just. That's one thing I've been learning lately, is that it's often a lot better to use from callable, and the reason why is that just it has to do with threading anyways. So let's see here. So I'll try and refactor this code live. So we're going to perform our calculation, and then that's going to pop up in our flat map down here, which is some RxJava magic. And just really quickly, one of the things I'm going to do with this application is I'm actually planning to take out the RxJava stuff and replace it with coroutines. Someone had a question about coroutines earlier. Anyways, so what we would do is after we perform our calculation, we would check the result. So I also need to change the validator's return type here to be of type result, and then that'll be, let's see, expression. expression result, and here that would be Boolean. No, that would be an exception and a Boolean. Sorry, this is all the stuff that I totally forgot to do ahead of time, and that's kind of why my demo got derailed here. I thought I had already converted this project over, and it turns out I totally hadn't, and I was thinking of a different project. So that kind of, and the other project, I can't actually show you the code. So that was kind of a big blunder earlier, but that's okay. Anyways, validate expression. So then we go into our validator. Okay, and so what you would do is, so I believe you would wrap, I think you wrap the function call. Oh, what would we do? We would wrap the function call. Right, so we would say flowable.just expression result dot build, and then we would pass in the value. We would pass in result, and result is just what can result be? Let's see here. iCalculator result. So that's going to be expression data model. Okay, what does expression data model look like? Okay, so how it would work is you basically you call it here, and because we have this build method, if for some reason the function we pass in, this is kind of the key that's the difficult part to explain here, is that we pass a function in to our build method here, and it's going to either create a value out of that function, or if the function throws an error, it's going to catch that error, and then it'll create an error version of our result. So that's kind of the thing I've been having difficulty explaining here. Whereas, so let's say, for example, we specified that the value we want to see out of this thing is going to be a Boolean, for example. If this was a Boolean, then what we would do is we call our function expecting it to return our Boolean. If it does, we create our value class. If it doesn't, we create the error class, and that's kind of how we dictate whether or not something is successful or not. And I'm just totally blanking on what this part here, down here does. v.toResult. So function, so that's going to be an extension function on v, it looks like. Yeah, this is the part I didn't take the time to just deeply understand exactly what's going on in this block of code, and so that's another reason why I'm failing, why I totally failed earlier. So this is vaguely how it's going to work. What I'm going to do is next week, next live stream, I'll do a much better, I'll make it my job to explain this a lot better, because that was, you know, I was kind of hoping to share a cool little construct here. And just because I didn't take the time to prepare the lesson ahead of time, one of my things is if I feel like I can't explain something well, I don't like to carry on with the lesson, because it's just kind of a big issue. Anyways, hopefully that kind of answers your question. Like I'll say, I will get back to this, and if you are interested, we have a Slack channel. Invite link just down in the description box below, and I'll make a post later detailing how we actually use this result wrapper, or either monad as it's actually called, in the rest of the application. But for now, hopefully that kind of gives you an idea. Like I said, hopefully at the very least I explained it well in theory, and the theory behind it is we want to be sending one object through our event streams, as opposed to using on error to handle just simple exceptions. We only want to be using on error, for example, in RxJava as like a catastrophic failure event. And this applies even if you're not really using RxJava. Anyways. Okay. Hey, what's up, Tina? Thank you for joining me. So again, the music, I don't even know, I'm just going to call you the music, is asking if I could explain coroutines in Kotlin. So the thing about that is I could give you like a vague theoretical thing, but I'm actually working on implementing it as I speak. So what I'll do is I'll save my explanation until I have some working code I can demonstrate for you. But coroutines are really damn cool. I think I have some notes on them. Do I have notes on coroutines at all? Yeah, I don't think I have my notes handy here. The basic gist with coroutines is that they're kind of like threads, except they're super cheap. And that's about all I will give you for now. They're a really, really cool idea, and they're definitely something you'll want to look into. But like I say, my understanding isn't quite there yet to be able to explain it deeply, so I'll just hold off on doing that for a little while. All right. So, anything else? That's a good question. So Tina's asking, so I said that I'll be replacing RxJava with coroutines. Does that mean that people shouldn't bother with RxJava? Let me think about that for a minute. So it's too early for me to say that for sure. But my impression so far is that probably RxJava is a little bit almost obsolete for Kotlin. And I would say certainly most likely over time there's just not really going, the overhead of adding it in as a library is probably not going to outweigh the benefits of using it. And the main reason behind that is just I can't think of many situations where you really truly need the power of RxJava, where, for example, Kotlin's functional syntax and extension functions, along with coroutines and threads, are not going to be sufficient, especially when you're using, for example, the either monad or the result wrapper. So my short answer there is, yeah, if you're just a Kotlin developer, if a Kotlin developer was wondering, should I learn RxJava, I'd at this point be inclined to say no. The thing about RxJava is that it's theoretically, to me, quite simple what it does, and you can explain RxJava just using diagrams like this. But the overhead cost of learning it and relearning it and adding the library, just adding to your method account, it's pretty, not the method count specifically, but all of those things combined is a pretty high overhead cost for something that it appears you'll be able to do quite easily in Kotlin itself. Because at the end of the day, what is RxJava? It's basically the observer pattern, which also allows you to deal with threading at the same time. So I could imagine a situation pretty easily where you could even build your own implementation of the observer pattern in Kotlin and kind of just use that. And I think that's actually what a lot of development companies do nowadays is they basically have their own implementation of the observer pattern. That's something I could explain later if someone's curious about what the observer pattern is. But essentially, if you've ever wondered, anyone listening's ever wondered, what is RxJava? It's like a really supercharged version of the observer pattern, which is relatively simple idea. So yeah, in a nutshell, although I love RxJava and I would continue to use it in Java projects, and I'm still using it here and there in my current development work with Kotlin, but I am actually looking to transition to using just coroutines exclusively, and then that way basically just leaning on the language features as opposed to leaning on APIs. And anytime you can replace a third-party API with a language feature and just kind of drastically reduce your overhead there, I think that's kind of a no-brainer. But that being said, I still really like RxJava. Anyways. All right, well, I think I'm going to wrap it up there today. We're about an hour in, and I am pretty tired here. Yeah, so just a comment from Tina. She's currently learning Android architecture components with live data, and Tina comments, I'll just read the comment out. I'm currently learning Android architecture components. Live data is really cool lifecycle awareness and persistence. I absolutely agree. I've been using, even in this project, I've been using, let's see here, view model from architecture components. Now, I believe you could probably actually achieve what I'm doing here with live data, but I am absolutely loving. Let me try and briefly explain why why I've really enjoyed using this. If I have see if I have one of my diagrams here. I'm not sure if I have one which includes. Okay, here we go. This will kind of work, I guess. So I debuted this sort of diagram a little while ago, which is like a basic, simple summary of what a typical Android architecture, or really any GUI architecture, will look like. And what it ends up looking like is, so we have our UI, and then we have our decision maker, which could be presenter, controller. It can, in some cases, be a view model. I don't use a view model as a decision maker class, because to me that is literally antithetical to the name view model. I actually use the view model as what's called like a front-end data store, which just stores session and temporary data. And why I love view model, and also live data is great for this as well, is that because they are lifecycle aware, they don't need to be dependent on listening to the view for the view's callbacks. So basically what that means is by holding your sort of session data, your temporary sort of view state in a view model or live data, for example, what you can do is you have a decoupled data store. And so you can basically still follow, for example, model view presenter, like in this project, with a temporary data store that is itself lifecycle aware. And then that also reduces the complexity of like having the view have to be wired into the view model, for example, which is how Google kind of, the Android team kind of recommends you do it. And I don't really like my view to be wired in to kind of anything but a decision maker. Anyways, there's different styles, but very happy with Android architecture components. It's pretty awesome. All right, everyone. Well, I'm going to call it a day for today. And once again, I apologize about my ridiculously bad lesson today on the expression result, the either monad. I hope at least I was able to explain the theory behind it, and then it's really useful, even though I wasn't able to explain in detail how to use it, which that's generally what I try and focus on. But pretty much what happened here is that as usual, I thought I had actually already changed a whole bunch of the code that I'm able to show you, such that it would make the demo a lot easier. And instead, what I had done is basically not made any of the changes I had thought I had made. And then I ran into a situation where I could copy and paste code, which I'm not really allowed to share at this point. Or try and just basically rebuild everything on the fly. And unfortunately, my brain was just not prepared to do that today. So I do apologize about that, but it is what it is. That's live for you. And yeah, that's basically it. Thank you for watching, everyone. I will be, I'm going to try and keep regular streams going every Monday from here on, now that I've finally caught up, and I'm really hoping that the contractors outside, I'm talking very quietly because they're right outside, but I hope they'll be able to sort their stuff out really quickly. So anyways, yeah, that's basically it. Thank you for watching, and peace out.